For those of you who have taken up trigonometry, I am sure that you know what a Pythagorean theorem is. But have you derived it? Or do you know how to derive it? Okay, in this video, I'm going to share two proofs of the Pythagorean theorem. Okay. The Pythagorean theorem is a statement about triangles containing a right angle. So it's about a right triangle. This famous theorem is named for the Greek mathematician and philosopher Pythagoras. And a Pythagorean theorem has more than 100 proofs. And it states that the area of the square built upon the hypotenuse of a right triangle is equal to the sum of the areas of the squares upon the remaining side. Okay. Now, considering this right triangle, the hypotenuse is the longest side, and the other two sides are called the legs. So, let's read it again. The area of the square built upon the hypotenuse. So, we will draw a square wherein one side of the square is the hypotenuse, like this one. Let's denote it as square C. Okay. Let's continue. Areas of the squares upon the remaining sides. So, we'll now draw square side. Now, one side of the square is the leg. Yeah. This one, square A, and on the other leg, square B. Okay. And again, let's read the Pythagorean theorem. The area of the square, this one, square built upon the hypotenuse of a right triangle, square C. The area of square C is equal to the sum of the areas of the squares upon the remaining sides. Squares upon the remaining sides refer to squares A and B. So, the area of square C is equal to the area of square A plus the area of square B, okay, equal to the sum of the areas of the squares. So, if we denote the side of square A as A, and then for square B it's B, and for C it's C. So this is side A, B, and then C. Therefore, C square is equal to A square plus B square. And this is the Pythagorean theorem. But again, the question is, do you know how to derive this one? So we are going to prove that C square is really equal to A square plus B square. Okay. Here's proof number one. Okay. Proof number one is this. Let's consider two identical squares. Okay. For the left square, let's draw a smaller square. Okay. And then also a smaller square here. And we're going to denote this one as square A and square B. Now, the remaining part are identical, no? Rectangles, two rectangles. And let's subdivide the rectangle into two. Okay, making it two right triangles. Same with this one. Okay. And so we have triangle number 1, 2, 3, and 4. Okay. So if we denote the side of square A as A, so A is an isa, and then also this one, A is an. And then for square B, let's denote this side as B and also this one B. So kanina side B sa isa as well as this one B. And then for the diagonal of the rectangle, C, that's C and then C. Okay. Now, let's transfer to the right square. What we'll do is, we are going to transfer the triangles. Okay, like this one, this triangle. Ate transfer dire. Ana. And then this one, this triangle, ate transfer there. And then this one, this triangle, let's transfer it here. And then this triangle, it transfer there. Okay. Now, this one is a square. Um, since this is a right triangle, suppose this is 50, 40 na yun, kay 90 man daw. So kung 50 na, 50 man sad na eh. So 50 and 40, 90. So 90 siya. Square na siya. Let's denote it as square C. Now, the next step is, if we're going to remove the four triangles there, same with this one, okay? Same raman sila, no? If we remove the four triangles, this is what will happen. So what remains is squares A and B sa left, squares C sa right. Therefore, the area of this square is equal to the sum of these squares, A and B. Kay ang area sa upat ka triangles, equal naman na rin. So, the area of this one, square C, is equal to the area of square A plus the area of square B. And square man siya, C square is equal to A square plus B square. Okay, that is proof number one. Okay. Proof number two is similar to this one. Okay? Similar to this figure. So, from this square, let's draw four right triangles. Identical right triangle. Okay? And then we have this one, square, square. So, it's obvious that the area of the bigger square, this one, the area of the bigger square is equal to the area of this triangle times 4, since identical man. So, 4 times area of this triangle, 1, 2, 3, and 4, plus this one, plus area sa this blue na square. So, area of bigger square is equal to area of triangle times 4 plus area of the smaller square. So for the bigger square, the length of the side is A plus B. So next step is this one. A plus B square man. A plus B times A plus B. 4. 4 times area of right triangle is 1 half base times height, or 1 half AB, and then area of smaller square, the blue square, C square. And so let's expand this one. Now you have a squared. This is a perfect square trinomial. The expansion is this: a squared plus 2ab plus b squared. And 4 times 1 half ab is equal to 2ab plus c squared. And since same lang, na-cancel siya. Therefore, a squared plus b squared is equal to c squared. Okay, so this is proof number 2. I hope that you have learned something and you're able to refresh what you have learned sa trigonometry na subject. Thank you for watching.